Hi, everyone. Welcome to this new lecture series on Mechanics of Solids 1. I'll be your professor for this course. My name is Dr. Azam Khan. So today is our first class, and the agenda of our today lecture is, first of all, I'll just introduce myself and welcome you all. Then after that, just briefly describe the course content, the outcomes and objectives. After that, examination, assignments and grading policy. And finally, the textbooks and references which you can consult. So, as I said, my name is Dr. Azam Khan, and I've got industry plus teaching experience. My areas of expertise is structure mechanics, finite element analysis, design of concrete and steel structures. I am based in office number 116 in Ski Nust. I'm available from 9 to 5, so it's an open door policy. You can just pop in anytime and we can discuss any issue which you have related to the course or even my mobile number is displayed on the screen. I always ask the CR of the class to set up a WhatsApp group. And then that is a very handy tool for communication. We can discuss problems, issues related to the course. And also, I mean, like the submissions of assignments, exams, and quizzes, and all that. We can discuss different issues. Okay. So that's a handy tool. Please set it up today. I'll briefly discuss what mechanics of solids is. There are two things which we will do in this class. One is stresses and strains, and another one is shear force and bending moments. But mechanics of solids coming under the umbrella of fundamentals of engineering mechanics. So fundamentals of engineering mechanics is statics, dynamics, and mechanics of solids. Statics and dynamics you might have done or you might be doing. Mechanics of solid we will be doing now, discussing that. The difference between statics, dynamics, and mechanics of solids is that in these two, you normally have rigid structures. So the structures don't bend, they transfer the load straight away. There is no deformation considered in them. In the mechanics of solids, we are dealing with those structures which are bending, which have got deformations inside, and our aim is to understand the deformations and stresses which are developed inside. In the statics and dynamics, you have externally applied load, and you try to find out your reactions or your movement, the forces, accelerations, etc. In the mechanics of solid, you have a structure under load, but you are trying to find out the internal forces, the internal distribution of stresses, the strains in a structure. So that's what I have written, that you have applied loads in mechanics of solids and you are trying to find out the internal effects. The internal effects which we consider is stresses, strains, deformations, shear force, bending moments, etc. But we always stay in the domain of small displacement. We don't assume that the displacements are very big. So just to give you an example, imagine we have got this rod which is pinned to one end, and we are trying to find out a load that will be able to lift this rod. This rod has got a weight W placed on it. So if it's a statics problem, then this rod is considered rigid. So this rod, no bending or deformation is allowed in the rod. But in the case of mechanics of solids, we consider deformations in this rod. We have to make sure that the rod is strong enough to take this applied load, and then how this applied load gets transferred to the support, in what way it deforms the rod, what sort of deformation is that, and what sort of stresses are generated inside. So that sort of thing is done in mechanics of solids. So let us go back to our slides. So based on whatever we have discussed, the course description, in the course description, we have two important things which are for us to learn. One is stress and strains within structure, the deformation. Another one is shear force and bending moment diagrams. So if you have applied load on a structure, how do you draw the force diagrams and the moments diagrams? So these are the two fundamental concepts which we will develop in this course. And these two actually are objectives also. So to understand the properties of materials, so that is again stresses and strains, different materials give us different stresses and strains. A chewing gum and a rod, a steel rod, their deformation is completely different. Different processes, yeah, are involved, different internal forces are involved. So we will try to distinguish different materials, and then importance of material properties in analysis and design of elements. So again, it's the repetition of whatever we have done or we have discussed. So the same rod example is applicable over here. Now let us briefly discuss the course contents. In the first 3 weeks, we will do simple stresses and strains, which will involve uniaxial strains, shear strains, and then Hooke's law, Poisson's ratio, and all that related to stresses and strains. So different type of properties which are used to describe the internal stresses and strains, all those will be discussed in the first 3 weeks. From fourth till eighth week, rather, I should say, we will do the bending theory, where we'll discuss the shear force bending moment diagrams, the bending moment formula, what is engineer's beam theory or Euler-Bernoulli theory. So that sort of stuff is going to be discussed in this under this topic. So it goes further. Yes, repeated. Sorry, this is repeated on the other slide. In the ninth and 10th week, we will do the torsion, another type of applied force, which is trying to twist the structure. And then we'll study what sort of internal forces and deformations take place when we apply that sort of loading. In the 11th till 15th week, we will do columns, so different types. So these are vertical members which are axially loaded. We will try to discuss the short columns mainly, a very brief review of intermediate and long columns, but that you will do at a greater depth in MOS 2. But columns are essentially axially loaded compression members. So those will be discussed in 11th till 15th week. Then 16th till 17th week, we will do some strain energy principles, virtual work equations. We will derive how the energy plays the load. Obviously, if we are applying the load on structure, we are actually pumping some energy in the system. So how to determine that energy which is going into the system, that will be discussed in 16th and 17th week. After that, 18th week, you will have end semester exam, and in the middle, 4th to 9th week, you will have a midterm exam. Okay, course outcomes and objectives. So as I told you, there are two main objectives of this course, which is A, learning stresses and strains, the internal forces and deformation. The second one is bending moment and shear force diagrams. So that's why, so you must develop engineering knowledge of these two requirements. So you will have to perform some experiments, and those experiments will actually enhance your engineering knowledge. The examinations, assignments and grading policies. So this course will involve 4 to 5 quizzes, 4 to 5 assignments. Then we would have a midterm exam and an end semester exam. The assignment will weigh 10%, quizzes 15%, midterm exam will be allocated 25% weightage, and the end semester exam 50% weightage. This will make 100% of your marks. Please make sure that you timely hand in your assignments. Before we end this lecture, let me just introduce these textbooks to you. So Strength of Materials by Pytel and Singer. That's a very important book you can follow. And another one is Mechanics of Solids by Hibbeler. I will try to stick to Mechanics of Material by Hibbeler. The latest edition is preferred. Strength of material is very good for developing concepts. So you can have other books also, very good books, Mechanics of Solid by Benham and Mechanics of Materials by Popov. These two are also very good reference books. But I think so these two books, if you have a copy of them, so that will be good for you. Okay, so thank you very much. And in the next lecture, we will start from stresses in structures. Thank you.